Okay. So Docker run hello world. What does it do? This question I asked you 1 month back itself. Okay. Tirumala, tell me, what does this do? Docker run hello world.
It runs the command.
What command does it run? Hey, you have to get very specific. I mean, we're all engineers, right, of some kind?
Yes.
Yes. Now you tell me, what does it do? Docker run hello world. What exactly is hello world? How does Docker know what the stupid hello world is? So it looks for hello world locally to see if there is a hello world image, and then it builds a container on top of that. It takes that image and builds a container and then runs it. Actually, container already built. So if there's image there, it will run. What if it doesn't find the image locally? What does it do? It picks up from the Docker registry. Okay. Okay. So these are some other useful commands. Docker search Redis. What is Docker inspect? We did this Docker inspect. Remember, when you give Docker inspect, it will give all the internal details of the container, the specification and everything. Remember, we actually searched for the IP address of the container.
IP address. Yes, sir.
Do you remember that?
Yes, sir.
Yes. Docker logs, we didn't do that, but we'll do it later. Okay. So now we talked about containers. Now I want anyone of you to answer this question. So what is that? Why is containers beneficial? Why should you even learn containers? Why are you even learning containers? And why am I teaching you containers? What benefit does it give to you or to the industry? What? Any one of you? Jagdish, Shiva?
Container is isolation.
No, but I'm asking why.
Okay.
And it is lightweighted and standardized format, sir.
Okay. So what does it give? So who see something will change, right? But it has got some business impact and some technology impact. Like we used to have like phones, landline phones at home, but now it's cell phones are becoming common. I mean, there's something that cell phones give what landline phones are not able to deliver, right? Like the mobility part.
Yes, sir.
Okay, so that's a distinct advantage, right? Just take the phone concept. Call somebody. Earlier you used to call and then nobody picks up. You think that okay, nobody's at home. Now cell phone, pretty much everybody picks up because it's always in their pocket or in the vicinity. So it's all the problem with mobility, right? Now, what is the thing that containers are bringing to you that you should be excited, or why is the industry excited about containers? We talked about it early in the more than a month. I mean, you guys are forgetting, man. Why at all you should learn containers? Sure, tell me why should somebody say, Rama is teaching a container. You should ask me why are you even teaching me? Why should I bother about containers? Of course, industry is talking about it. That's a different thing. But industry, when it chooses to move in a direction, there's got some purpose. Tell one distinct thing that advantage over conventional virtual machine. I mean, so one simplest. Remember, last time we ran an Nginx web server, right?
Yes, sir.
Okay. Now think about that. If you have to run that without a container, right? Okay. I mean,
yes.
what would that mean? So containers, I mean, the simplest thing is that you're getting more juice out of the same hardware. In simplified language, right? You're now getting more juice. So remember, 30 years back, the way vegetables and fruits have evolved. I mean, oranges were not this juicy before. Now the fruits here are a lot more juicy. Why is that? What happened? So they did hybridization and then added the gene that will produce more moisture content in the fruits. Okay. And I mean, even 300, 400 years back, the rice used to be different. It used to be mostly wild rice. Right? Now things have evolved. Okay. So with containers, you can actually launch maybe 100 containers in a machine. Take a physical machine, right? But in case of like a virtual machine, you can launch how many? Maybe 4 or 5, right? So that gives you, and then coupled with isolation, you can actually have more tenants. You know, tenants, you're running your containers. Think of it as like containers provide you isolation. Okay. Okay, so let's move on. So what are the advantages? It also runs fast, dies up fast. That's a big advantage. Okay, so when somebody say it gives you isolation and lightweight, and you can launch a lot more containers on a machine compared to VMs. Okay, so does this mean it's the end of the virtual machine? So we are now doing to virtual machines what virtual machines did to physical machines. You understood this? Remember, one physical machine, you have multiple VMs. Now you have containers, bunch of containers sitting in a virtual machine, and they're all self-contained, isolated. So you have to think of containers as another weapon in the arsenal of cloud developers. Okay, yeah. So
Okay.
let's move on. This nothing much more on this. Okay, open container initiative. So one of the things I want you guys to do is like do some research on this. What is this open container initiative? So what's the mission of the OCI? The mission of Open Container Initiative is to promote set of common minimal open standards and specifications around container technology. Now containers are developing. I mean, you have Linux containers and then Windows containers are coming around. You should have some standards. Why should you need standards? Tirumala, tell me why you need standards. It's a simple question. It doesn't have to do with cloud. Tell me, give an example of standardization. Guys, I want you to open up. Give an example of standardization. Why is it useful? Thirumal?
Sir.
Yeah, tell me. I'm not talking about containers, but tell me standards in your home. Everything is standardized these days. What are thinking about?
Rama, we can take an example of a electric board where 3-pin plugs are set
Yeah.
in a
3-pin plug is a standard.
standard. All the switches comes around.
Yeah, and then the adapter for your gas cylinder is standardized. Sockets are standardized. Your switches are standardized. Okay, not switches, but plug points.
Yes, sir.
What else? Your traffic lights are standardized. I mean, what is not standardized? Your exams are. And what are the benefits?
Wide accessibility means user can use their products means whatever the different types of the products, but
But
for
use
that
one
contact
word to
point,
describe everything. One word to describe everything. See, that's a thing that you should have to use in your vocabulary when you attend interviews, right? So it encourages portability, right? Now,
yeah.
the socket, the plug, your uh, adapter is there. You take it to a hotel and then plug it in, and it just fits in, right? Go to another hotel in another city, it fits in. So that is what portability is. So when you have open, when you have standards, portability will increase, right? So that's the same thing with the operating system, okay, and containers. So the thing is that the thing where Jagdish develops a container and hands it over to Nikhil, it should work, right? And it's able to
Yes, sir.
work because you follow same standards. Remember early on I showed you a picture of ship with containers, and then it's the same thing will sit on a truck, and then the same thing will just go on a train,
Yes, sir.
right? Your broad gauge, narrow gauge tracks are all standard. I mean, you think they have different gauges? How it will change tracks? So the word I'm talking, I would expect from you guys, use portability. It's a very understood thing. So when you say why would you say portability? That's all there is. And the reason why we have standards and containers, because it has to be portable across Amazon, across Google, or across Azure. The container should just seamlessly move. Okay. So what are the governing principles of OCI? Now I want you guys to do some research and then do some learning on this. Okay. Look at Open Container Initiative. There's a huge amount of document and literature. So what does it provide? Technology leadership. So the big guys will come together and define standards because they know the stuff. Okay. Influence through contribution. So you can contribute to those standards. Limited scope, limited politics. I think that's what is more important. Minimalistic structure, representative leadership. Okay. So cloud native. What is cloud native? You keep hearing about this cloud native. Okay. In the cloud native is the approach to building and running applications that exploits the advantage of cloud computing delivery model. I mean, this is a much bigger concept than the statement what it says. If an app is cloud native, it is specifically designed to provide a consistent development and automated management experience across private, public, and hybrid. Now, so we can keep on talking about cloud native, but in simplistic terms, right? First of all, cloud native also means it has to be containerized. Okay. Then otherwise, there's no cloud native. It has to be containerized. It's about an application being cloud native. So take that application, it will use some standards, and then it integrates with first of all, it follows a consistent development model. Like, for example, what is a consistent development model? Jenkins, okay, build process. Okay. Now the reason why the process consistent development is because you take your application and all the dependencies and move from public to private, right? All of these will just plug in. Okay. I'm kind of struggling to figure out a real world experience that illustrates this. But anyway, when I remember it, I'll let you know. So it's cloud native. So cloud native and then OCI, they go kind of together. So you should keep thinking about cloud native, how you design your applications, and so on and so forth. Okay. Okay. So this is what it is. So let's talk about Kubernetes. I'll give an intro to Kubernetes. Kubernetes is a pretty challenging subject. Okay, so what have we learned so far in terms of containers, what do you think would be the next step? Guys, so now you have containers, right? So we created what? We created a Redis database as a container. Okay. And then what else? We created Nginx. What is Nginx, by the way? It's a web server, right? What, Shiva?
Sir,
Nginx. What is Nginx?
it is a web server, sir.
And
Nginx is.
yeah, and last time in our tutorial, we so that it was printing hello world, right? It's simple web
Yes,
server.
sir.
Yes, sir.
Yeah.
Now we talked about Redis and then so almost there are plenty of applications that are containerized. Okay. Now the next question is obviously you have hundreds of containers running. So and then they're coming up fast and dying fast. And imagine on a single machine you have like 50, 60 containers. Okay, and these are in some way applications, right?
Okay, sir.
The web server we talked about and the data. There's some kind of applications. Now the next step comes like, okay, how do you manage this? Now let's say, think about this container as a school, right? And then you, first of all, what you need some mechanism to manage them, some mechanism to bring in new students and manage outgoing students, right? Think about new incoming students are like creating containers. Okay. And then you have to put them in the right place, right classroom. And then you need to have principal. Think of the principal as the coach or the manager. Okay. And then teachers. Who are the teachers? Teachers are the representative of the principal, right? Every classroom has a teacher. Okay. And then the teacher acts based on the directions of the principal, right? Now think about what is called. It's called management of students in the school. Okay. It also called orchestration. Primarily when you think about continuous orchestration, like how do you bring them up? How do you manage them? How do you manage the life cycle of it? What do you mean by life cycle when I say?
It's an entire process
Like what?
from beginning to end.
What do you mean beginning to end, man? Life cycle is about how do you create a container, with what image do you use? Okay. How do you run
Yes,
it?
sir.
Build, run, and then how do you kill it? How do you terminate it? How do you clean up? Or even how do you upgrade image? How do you upgrade from one container image to another container image? Let's you have
Okay, sir.
Nginx 1.0, now you have 2.0 image available. How do you that's whole life cycle? Okay. Life cycle also means what is it doing? Right? Okay, you started it, and then what the heck is he doing? If that guy is struggling for resources, that's also management of the life cycle. If the container is getting into an error state, I mean, what happens in the current container is into error state without any control? What happens if the student doesn't study? Who monitors? Guys, I'm asking a very simple question. A quick answer.
Yeah, class teacher or principal, sir.
Yes, class teacher. Let's say, yeah. I mean, principal wouldn't know because he has got the class teacher would know,
Yeah,
right?
class teacher. Yes, sir.
And how do they do? How do they do? I mean, how do they measure that student is really doing anything or not?
Exams, sir. Conducting the
Okay.
exams.
Okay. Now remember these analogies because in Kubernetes we'll see all these.
Okay, sir.
Okay. So I'm building the analogy first. So think about school, principal, and then teacher. Okay. And then the flow, and then monitoring. Okay. So let's get started.
Okay.
Okay.
Okay, sir.
Okay.
Okay.
So we'll get into, okay, there is Katakoda tutorials on Kubernetes. Okay. And we'll walk through one Kubernetes simple example before we close session. But I want you to know, okay, Kubernetes is a platform to orchestrate the deployment, scaling, and management of container-based applications. Okay. Now this is a fairly complicated term, but think about orchestration is like managing the deployment. So we're not talking about deployment, scaling. What does scaling actually mean? Jagdish, tell me what scaling means.
Scaling, updating.
No. Scaling, not updating, boss. Who else? Thirumal? Hmm? You know what happens when the train is full? Sometimes they add an extra coach.
Okay, sir.
There are too many people waiting on the waiting list, so sometimes they add an extra coach to a train. Do you know that? I mean, do you even know that happens? See, when
Yes,
the
sir.
APSRTC, right, on festival time they put extra services. What exactly are they doing? What do you think is that happening there?
They're increasing the, their transport facility.
No. What do you mean increase in transport facility? Because see, what I want you guys is come down to a level that a common human being can understand. Okay, so Dasara festival is coming. Okay, now Hyderabad to Vizag, there are 30 buses every day. Now there are too many people. What would APSRT and Telangana would do?
They're increasing the services.
Increasing the bus facilities, sir.
Yeah, additional. Yeah, say that they're putting more buses.
Additional. Yes, additional. Yes, sir.
What exactly is that? What would you call that thing? Are they like modifying?
They're scaling.
That is called scaling. That's a good example of scaling. So remember all these things. That is a good example of scaling. What happens after Dasara? What happens?
Sorry, sir.
What happens to the buses after Dasara? What happens?
They're again stop the services, sir.
Yeah. So
Because
this is what we call scaling up and scaling down.
Yes, sir. Yeah, scaling up and scaling down. Right.
Right. You got it?
Yes, sir. Got it.
Yes, sir.
Okay. Now in technical language or in economics language, you're actually the demand and supply are elastic kind of a thing, right? So if there's a lot of demand, right, then what will they do? The supply will increase.
Okay, sir.
Right. So that is actually called, I mean, this scaling up and scaling down, but the ability to do that is called what? Elasticity. See, we talked about elasticity in the cloud in the very first class or so. Cloud is elastic. You know this rubber band? You know rubber band, right? So Thirumal, you walk me through with this. This rubber band, what is it? Compared to a piece of thread, what is rubber band? Thirumal, come on. Speak up. It's elastic, right? I mean, what do you do with rubber band? You stretch it.
Yes, sir.
Yes, sir.
Right? So if you want to tie anything, what would you do? You don't push a thread, right? If thread is fixed, you can't tie sometimes. So rubber band, what? I mean, it's bigger, smaller, it will wrap up, right? So cloud is also elastic. Kubernetes is elastic. Okay. So remember we started one application with one web server we started, right? Nginx in our container. Remember we started in the last exercise last week. That is not elastic because it's only one. What happens if the web server receives lots of requests? if it will, to the extent possible, it will take. After that, it will probably die or get into an error state, right?
Yes, sir.
Now, Kubernetes will take care of management of all those stuff. That's what it's called, life cycle management. Like, for example, Kubernetes will automatically start another web server if the load is heavy. Okay. Now, one thing guys should pay attention. Containers. I mean, if containers is challenging, Kubernetes is a lot more challenging. In fact, I will not go through that in detail because you guys will feel miserable. Okay. So Kubernetes is a platform that encompasses a huge number of services and capabilities that keep growing. Its core functionality is its ability to schedule workloads in containers across your infrastructure. Think about it in the school, right? The students are joining. Okay. And depending upon the class, the principal or somebody on his behalf will distribute the students across various classes, right? This guy is going to 7th grade, the other guy is 9th, and then another kid is 5th grade, and so on and so forth. So you know that drill. Okay. And then the principal with his staff would monitor everybody. Okay. Now, primarily, what is the teacher's role here? Teacher is something like the agent of the principal. I mean, the teacher would teach, but primarily agent of the principal, right? They have they have like what? A curriculum, right? So do this in the next 6 months or 1 year. Okay. Think of that school analogy when you think about Kubernetes. Okay. Support several container engines such as Docker, Rocket, CRIO. Okay. So what are the Docker engines? What are the container engines that you have used so far? Jagdish? What container engines are you familiar with? Thirumal?
Sir.
What? Guys, the answer is there on the screen. What are you looking at? What is Docker? Docker is a container engine, right? So container runtime interface, CRA, provides various integration levels to other container engines. Okay. So Kubernetes provides the following benefits. Microservices, by breaking an application into smaller and manageable scalable components. Okay. Fault tolerant cluster, in which if a single pod replica fails due to node, for example, another is started automatically. Horizontal scaling, in addition, in which additional or fewer replicas of pod could be run by just modifying the replica setting in the replication controller. What is fault tolerant? What do you mean fault tolerant? It's a verb, guys. It's an adjective. Tell me, what is fault and what is tolerant?
It is ability of system fault tolerant.
Ability of the system to avoid any faults.
What is the background noise, man? So, okay, how does it avoid faults? What is a good example of fault tolerant system in everyday life?
MCV, you can in the electric appliances, you can take that as an example.
No, let's get very simple. MCV, not many people know what MCV is. Let's take something very simple. Anybody?
Fuse wire.
Well, the fuse wire is not exactly fault tolerant because it's only a more like a safety thing. So think about this aircraft, right? Aeroplane. What happens if one engine fails? What, Thirumal?
It has the buffer engine, sir.
What? It has a buffer engine?
Another engine is starting works.
So, okay, to some extent, right? If one engine fails, right, it can still fly.
Yes,
but
sir.
still- so, which means, it will still fly to the next destination. That is some example of fault tolerant. Like, for example, if you think about Boeing 747 or Airbus A380, which has got 4 engines, right? If one of them fails, no big deal. So, but tell me one good realistic example, man, fault tolerant. In fact, some of the hardware tools, right? They, they are made of rubber handles. Even if they fall off the ground, they don't damage the ground or they don't break. Think about something that falls off and then doesn't break. What would a good example be? Now, in the tire industry, the new kind of tires are coming that are puncture free.
Yes, sir.
You heard about them?
Yeah, sir.
Yeah, you can't puncture them. Right? That's a good example of a fault tolerant system.
Okay, sir.
What else would you consider? Okay, so I think okay, let's move forward. Horizontal scaling. What is scaling? We talked about scaling, right? Scaling up and scaling down. What is horizontal scaling?
Some specific functionalities.
Okay, what is horizontal and what is scaling? So we talked about scaling. One of you said scaling up and scaling. Scaling means what? Good example is Hyderabad, Vijayawada, Dasara festival. So more buses will be put up. Scaling up. What is
Yes, sir.
scaling? Horizontal scaling.
I can take one example.
Yeah. Tell me.
So the thing is that if there is any festival, so the thing is that if there is one single train, you add wagons to that
Yeah.
single train. So it will what this whole scenario is. It is a kind of the vertical scaling. Since this is one train and you added bogies behind
Yeah.
it. And so the horizontal scaling is a different kind of if there is a festival season and if you instead of adding wagons to the single train, you just increase the number of the trains. So that's
Yeah.
kind of the horizontal.
Yeah, so you understood, guys? I think he explained it well. Did you understand what's horizontal scaling and vertical scaling? We're not talking about, but think about it. See, these are all terms that they didn't invent out of thin air, right?
Yes, sir.
Think about vertical scaling, right? Or let's take bus analogy. Okay, the bus. Okay, so vertical scaling would be instead of putting a smaller bus, you had a bus. Okay, Hyderabad to Vijayawada. Okay, you have buses. buses have got 50 seats. Okay. Now, what APSRTC or Telangana would do is like vertical scaling. So remove the 50 seater buses and put the 70 seater buses. Now you are getting like huge, big buses now, right? 70 seater buses. Okay. So earlier you're running 20 services. Yes, now still running 20 services, but the buses are big, right?
So,
That is
okay, sir.
vertical.
Capacity.
Yeah, vertical scaling. But it is vertical scaling. Okay. Or
Okay, sir.
alternatively, what APSRTC do is, okay, we'll use the same 50 seater buses, but instead of running 30 services, we'll run 40 services. That is what? That's horizontal scaling. Okay.
Okay, sir.
So we'll revisit this over and over again. Now, nobody asked me what is this when I said pod. Nobody asked me what is pod. I mean, for the first time, you guys are hearing pod and nobody bothered to even ask me what are you talking about pod now. What is this pod? Okay, what is this pod in a conventional sense? Office में pod रहते हैं ना pod. What is a pod in the office? Those who are attending office will know this. Come on, Jagdish. What is a pod? You know groundnuts, right? You know groundnuts.
Yes,
You
sir.
guys have seen groundnuts, right? Now tell me, how do you get these groundnuts? The palli.
Yeah.
How do you get it? Go to the plants. Guys, come on, man. Hey, why are you silent? I'm asking you to describe how you get this palli, mumpalli. So you have plants. Now, how do you get these? Trimala, tell me.
It holds the seeds.
What is it called? There is something, right? And it has got two pallis inside that. Sometimes one with one palli. Sometimes 3 in 1. What is that called? That is called a pod.
Pod. POD. Yeah.
Right?
Yes, sir.
Yes. So see, guys, this Kubernetes guys did not just pull it out of thin air. There's a reason why they call it a pod. I'll tell you later. And what other examples can I give? Similar to peanuts. You know that batani that we eat, green peas. They're in a pod, right? And each pod will have like maybe 5 or 6.
Yes, sir.
7. Right?
Yes.
What else? Come on. Give examples fast.
Pista.
What?
Pista.
So in our office, what happens is there are these corridors and then there are cubicles to the left and right and all that stuff.
Yes, sir.
Okay. There are 20 cubicles on right side, 20 cubicles on the left side, and then so on and so forth. And then a couple of years back, maybe 5 to 6 years back, what they decided is no. So all the cubicles were individual. Okay, they're like 5.5 feet height. So unless you peep your head into the cubicle, you don't know who is sitting there. Okay, got it? Now, what happened, right? So instead of this 20 cubicles, what they did is they reduce the height. Okay, they reduce the height of the cubicles and then convert them into something called pods. It's like 4 people in one. They have the same space. Okay, like think about like a 10 feet by 10 feet and then 4 people sitting in each of these corners. Got it? So in office, we call that as a pod. So this 20
Yes, sir.
people and then into 5 pods or maybe 6 pods depending upon things. That is technically a pod. But think about so that's what pod as a noun means, right? So he got that message. Okay. Now in the container world, now we are moving to Kubernetes. We are not going to talk about containers, but we are going to talk about pods. So what changed here now? So a pod can have inside one container or two containers or three containers. Normally it won't be more than that, because if it is more than that, then it's good you start redesigning it. Got it? So in Kubernetes terms, what is a pod? Pod has got one main container and then two assistant containers. Think about like that. Or it can be three containers of equal weightage. Okay.
Okay,
And
sir.
we see so many examples of it, but the pod is what it is. Pod has got one container or two or three containers at most. Nobody will put 4 or 5 pods, put containers in a pod, because that's a bad design. Okay, we'll not go into that. Okay, now you understood horizontal scaling. Okay, so henceforth we'll
Yes, sir.
only think about pods, no more containers. And each pod will have, again, you remember, each pod will have its own IP address, and then the containers inside that pod will share the same IP address but with a different port number. Okay.
Okay, sir.
We'll see
Okay.
that in real examples. Okay. Okay. Where are we now? Okay. So what does Kubernetes provide? Replication and auto scaling. What is the replication?
It's the same image.
Okay, duplicating it. Yeah. Okay, what is auto scaling? So we talked
It's
about
depends. Sir, it is depends upon requirement. It will be scaling up and scaling down.
how is it different from the bus analogy? So what is auto here?
Okay.
No, what is auto? So somebody, so in the APS RTC case, right? Is there auto scaling?
No, sir.
Okay, how do you implement auto scaling there? What do you have to do?
They have to add it.
Okay, yeah. So let's take this simple example of MMTS, not MMTS. What is that? Hyderabad Metro, right?
Metro, Hyderabad Metro. Yes.
Hyderabad Metro is like driverless, right?
Yes, sir.
Okay, so right now they're running, let's say, whatever destination source and this, they're running maybe 5 trains an hour. Let's take a simple example: 5 trains an hour. How do you auto scale it? If you have to auto scale it, what would you do? I took driver as an example because there's no human element there. We have to see, whenever you say auto, what does it mean? You have to remove the human element there.
Yes, sir.
Okay. Now tell me, how do you auto scale it? Design. Okay. Tell me a simplistic algorithm. Let's give a chance to Tirumala. So Tirumala, tell me, how do you auto scale that? Your Hyderabad Metro. Take a simple example. I mean, you see, somebody has to design it, right? Let's say you're in charge of auto scaling it. You have to set some parameters, right? Where do you start? The trains are getting crowded, right? People are on the platform, but they're not able to get the train. Train is full, right? Tirumala, are you listening? Yeah, tell me. And would you decide to scale after the trains are full or before? And what would you do? And where would you measure? Take a single road, only one line. How do you do that? And you know, every day your 4 lakh passengers are taking the train, and you have details about every hour how many people are taking the train. So how do you scale it? How do you auto scale it?
Number of trips increases.
What? No, but are you understanding scaling means? Where does scaling come? I mean, let's go back to that bus analogy, Dasara festival.
Yes.
Okay. When do you decide you need to put more buses?
When the passengers are more.
Okay.
Only
Now come to
festival time.
Okay.
yeah, festival time, yes, but the primary thing is passengers. I mean, there's pandemic and then there's festival, still nobody cares. No, not going to put buses. Okay, now you tell me, so passengers, right?
Yes, sir.
So how do you do that on the metro now? Come back to the metro. Tell me, how do you set it to auto scale?
Maybe.
So every hour, you know, that last 1 month, you know, every hour you're getting 40, you're selling 40,000 tickets an hour.
Okay.
Okay. And then the services are sufficient. Let's take, for example, okay. Now, train capacity is what? Maybe 50,000. Now, when do you decide? When do you decide that you need to auto scale? And how do you even decide that it's time to introduce? I mean, let's say it's manual, right? Manual, you see that people are standing in the platform, not getting trained. Then you decide to put one more train. But in Hyderabad Metro, which runs driverless, how do you do it? So let us say you design the algorithm and say that, you know, the moment the passenger ticket sales hit 45,000 per hour, send one more train. Simple, right?
Yes, sir.
What do you call that? The whole thing. So you don't have to sit and count, just figure out all that, because the moment the number hits 45,000, then automatically another new train will start. So instead of 5 trains, you'll run a 6th one.
Okay, sir.
Got it? And that is what happened. That is auto scaling. So what is the criteria? You set a number, right? Like what? Percentage of utilization. The train capacity is 50,000. You're hitting 45,000, whatever it is, 90%. So once the resource usage is 90%, start additional train. Okay. So normally they will keep a criteria. You know what? It's like 80% threshold. Once it exceeds that, put additional 80%, so that it will go to 85 and then fall down to 80 again, because you're putting more additional train services. Okay. So Kubernetes behaves something like that. Okay. So when I say additional trains and all that stuff, it's about, remember, starting an additional pod, or starting giving more resources to the existing pod. We'll talk about all that stuff later. Okay. Now, Kubernetes concepts include pod, service, and replication controller and nodes. Okay. So some of these we can come later, but cluster. Let's talk about cluster. What is a cluster? In conventional language, what do you call it? A cluster. So cluster is a group of.
Cluster is a additional. I think.
No, cluster is okay. So a bunch of computers joined together by local LAN or whatever. I mean, so
Okay.
and treat them as one unit. So cluster is a collection of nodes, including other resources such as storage to run Kubernetes applications. A cluster has a single Kubernetes master node and 0 or more worker nodes. A highly available cluster consists of multiple masters or master nodes. What is high availability? What do you mean by high availability? What is high availability in conventional language? suppose that in that APSRTC is running a bus service, right, from Hyderabad to Vijayawada. What happens if the driver doesn't show up? The service will be cancelled.
Another.
Hmm?
2 drivers are there.
No. Okay. For Vijayawada, there will be only one driver. You don't need 2 drivers. Vijayawada is only 5 hours, right? Why do you need 2 drivers? But you understand my question? What is high availability? What happens if the driver doesn't show up? Jagdish,
Yes, sir.
what happens if the driver doesn't show up? Will they cancel the trip? APSRTC will cancel the trip.
They have the additional manpower, buffer manpower also available.
Yeah. So how do they decide? So they'll decide the driver has not come. So then they'll go around looking for a new driver. It doesn't happen like that, right? They all have a pool of
Yes,
people.
yes.
If the guy doesn't
Yeah.
show up for any reason, you know what, that guy is coming to, he's driving and then he meets with an accident, he's in the hospital, whatever, or he's sick. There are spare drivers available who will just jump in and then the trip will resume, right? Right?
Yes, yes, sir.
Yes. So a highly available cluster consists of multiple masters or multiple master nodes. Now we didn't talk about what is master and all that stuff, but we'll talk about that in great detail. But I'm talking about touching upon other terminology. So anything that is highly available means even if one of the machine goes down, nothing is affected. Got it? So what other examples can you think of? Same thing with pilots. If a pilot doesn't show up, the flight will stop. No, right? Or the government doctor in a hospital. I mean, I know how government doctor behaves and all that, but doctors, there's high availability there, right? So remember, we used to, when we were kids, there used to be frequent electric supply failure in Hyderabad. The power used to go off for like a couple of hours. It used to go off whatever time it goes and then it comes back right. So how do you make it highly available? What do you do? Guys, how do you make it highly available?
Sir, you're using the UPS.
Yes, that's a good example. You're using the UPS or at home you use the inverter and generator and all that stuff. So as soon as the power
Yes,
goes,
sir.
they will come on.
Yes, sir.
That's a good example of high availability.
Yes, sir.
Okay. Now, okay, I think we will wrap up for today. I think so, guys. What I want you to do is go and dig up Kubernetes research. What is it? What is
Okay,
the meaning
sir.
of Kubernetes? What is the meaning? It's a Greek word. Kubernetes is a Greek word. Okay, what is it? Do you know that symbol? What symbol is this?
Mhm.
What is this? What is symbol, guys? Come on.
So, it's a wheel.
What wheel? Is a tire?
Yes, sir.
Is a tire?
No.
Okay, this is the steering wheel of a ship or a boat.
Yes, sir.
large boat. So how was the steering wheel of a boat like 100 years back? This is what it is. Nowadays, everything is automated. You don't have any steering wheels. This is a steering wheel of a large boat. This is what they used to turn and do whatever they do. Got it?
Yes, sir.
So in Kubernetes, everywhere you will see the vocabulary is related to nautical engineering. Sea, ocean, and all that stuff.
Okay,
So
sir.
where did the word pod come from? What's a pod in the sea, in a sea vocabulary, ocean vocabulary? What do you call a group of lions?
Sir, group up?
A group of lions, what do you call?
Pod.
Group of lions is not called pod. A group of lions is called pride. P-R-I-D, pride.
Yes.
Oh, sorry. Right. Yeah.
Right.
Okay.
Yeah.
So where does so what is okay in the ocean vocabulary, right? What do you call group of whales?
Shul, I think.
No, it's called pod.
Okay.
So a group of whales is called a pod. So now why whales? So that's what I'm saying. All this vocabulary is related to ocean, oceanography, navigation in the oceans and things like that. Okay. So that's how when they say pod, when I said pod, right? A pod is actually a group of whales. Okay. What about what do you call a group of fish?
School of fish.
Yeah, you call it school of fish. Okay. Okay, so that's about Kubernetes for today. So these all vocabulary is interesting for you to remember. Okay.
Yes, sir.
So they don't.
So what about
Yeah.
what is the exact meaning of Kubernetes, sir?
Yeah, Kubernetes is that steering wheel of a boat.
Okay.
So it actually can also mean the captain of a boat, depending upon how you interpret it. Is the one who has got the wheel, but it is a word from Greek language. So you will hear about Greek languages and all that stuff. In fact, even container is the way we define, right? It's in the shipping containers. So whenever somebody talks about containers, it means shipping containers. Okay. Any questions, guys?
No, Rama.
No, sir.
Okay, so we'll wrap up for today, and
Okay, sir.
we'll and then see whatever I told you today. You go and do your own research. And I'm not giving you these slides because I think you're just listening to it. You don't even read it. I want you to go to the internet, search for what is Kubernetes, why do you need Kubernetes, and all that stuff. Okay. If you
Okay, sir.
okay. So Thirumal,
Oh, sir.
yes, research on. So two things I'm giving you homework: Open Container Initiative, Cloud Native, Kubernetes. Now, if you live in this ecosystem, right, you'll automatically figure that out, but you have to do that.
Okay.
Got it?
Okay.
Okay. I think we can. If you have any questions, if you don't have any questions, you can wrap